All right, let's break this puppy down. This is dedicated to anyone who feels like, hey, I'm great in school, but man, when it comes to these tests, they got me dogged. Don't worry, you're not the only one. Plenty are in the same boat. High GPA, low GPA, it doesn't matter, and everything in between. Everybody is jammed by this test. The one thing you can count on is that you're going to have some terrific direction by some terrific people out there. You just have to find the right person to work with. I feel that I am a very good person to work with. So now, instead of just holding on to the information, just sharing it with my students who pay for the program, I'm just going to share with everybody. I've had friends who told me, hey, you need to get this out to more people because you should let them know. You know, there are going to be folks you'll never meet and they could be in, I don't know, anywhere in the country or any different part of the world. In fact, I got contacted by a school in Colombia. Yes, South America. So that was pretty cool. And I've got contacted by a student in New Jersey and somebody else from Oregon just from posting these videos. That's pretty interesting. All right. Anyhow, let me stop chitter chattering and let's get down to business. This is Last Minute Advanced Math, page 66. And what did Mama say? We better break down these tests. All right. This is the last page. Let's see what we can do with this. Now, this is a question number 5. They're going to be, again, they're going to be certain topics that are covered in advanced math. But what I've done is I put these different questions together so you can see patterns with these questions. All right, this is question number 5, so it's an easy question. I see this going on here, and I might want to distribute 2n plus 2p, but be patient. I go into the question. It says a given equation relates to positive numbers m, n, and p. Which equation correctly gives m in terms of? So whenever you see the words in terms of, it simply means solve for. Solve for what? Solve for immediately what came before it, m. Now, sometimes your answer choices will, like this one, show you, oh, m equals, m equals, m equals, m equals. So clearly we're solving for n. But when you get to harder questions, sometimes they won't show the m equals. They'll just show you the answers. So that kind of throws students off. But let's pretend they're covered and see if we can solve for m because we saw in terms of. So let me rewrite this, 7m. I know most of you guys got this, equals 2 times the sum of n. Oops. Bad, bad, bad. Written too fast. N plus P. All right. If I'm going to solve for M, what do I have to do with that 7? I'm dividing 7 by both sides all the way across. So now 7 over 7 is just 1. So that's M equals 2 times the sum of N plus P over 7. Which one is the best answer? Ooh, 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 in and out of the question. But you have to do it carefully. All right. Don't rush because these guys like to give you answer choices that kind of look the same as what you came up with, but you might bite on the wrong answer. All right. Question number 16. I see this going on here with this equation. All right, that's not too hard. And plus, question number 16 is probably, I'd say like medium. It could be right on the board of medium hard. Let's go into it. The given equation relates to numbers j, k, and n. Which equation correctly expresses k in terms of? What does that mean for? What does that mean for? What does that mean? That means solve for. Solve for what? K. Again, anytime you see in terms of, it means solve for. Solve for whatever came immediately before the words in terms of. All right, let's take our 14j plus 5, and we're solving for k, equals m. Now, first step, I want to get rid of that 14j. Now, that 14j is added to 5k, so that means I'm going to subtract the rate. Does that subtract rate? Is that a word, subtract rate? Well, today it is. I'm going to subtract rate, which will cancel this, so all I have left over is 5k equals m minus 14j. I can't talk today. How do we get rid of that 5? We're going to divide 5 all the way across. So now we're going to have k is equal to m minus 14 Jordan all over 5. So where do we have m minus 14j? We ain't got it here. We got it here, but it's got to be all over 5, so we can kiss that goodbye. And then we have 14j minus m. No, that is wrong. But we do have m minus 14j all over 5 right there for answer choice A. All right, let's diggity dank. Let's go to the next one. Ooh, ooh, ooh. Advanced math in terms of, question number 19. This is supposed to be a hard question. Oh my gosh, I'm cracking myself up. All right, now this guy, we see this equation given to us. Now, in the question, here's where students get confused. They say relates to variables n, t, and w, where n is greater than 0, t is greater than 0, and w is greater than t. Pause. What do they mean by this n is greater than 0 and t is greater than 0? Well, n, if it was 0, right, is 12 over 0 number. Is t, if it was 0, is 2 over t a number? No, those are called undefined numbers. Here, I'm going to write it so it imprints in your head. Oh my gosh. Undefined. I was going to put undetermined. Undefined numbers. Anytime you have in the denominator a number, so let's just say 2 over 0, it's undefined. It is not a number, no equal number. All right, now we go into the question. We want to solve for n. All right, what's going to be my first step? Well, I see this going on. I'm going to add 2 over t to both sides, so it cancels this guy out, and it'll be over on the other side. In fact, let me just rewrite it. 12 over n is now going to be equal to, why? Because I'm adding um, the 2 over t. Remember, it's minus 2 over t. Now I'm going to add it to both sides so I can get rid of it from this side. Got it? So now it's going to be 2 over t minus 2 over w. All right, here's the other part where they're trying to jam you on a quote unquote hard question, meaning that most students get a little lost in this. We don't have common denominators. So if I'm going to add or subtract fractions, I need common denominators. Right now, I don't have them. So what would happen if I could make them common denominators? I'll multiply this side by w, which means upstairs got to be multiplied by w. This side is going to be multiplied by t, and then upstairs, that would be multiplied by t. There we go. Now we're halfway home. 12 over n is equal to 2w minus 2t. And I could put it all over tw. Got it? So the expression could be written like this, or it can be written like that. Either one, they're interchangeable. We cool so far, ladies and gentlemen? All right, so then what is going to be our next step? We've got to solve for n. Now notice on the left-hand side of my equation, I have 12 over n. What happen if I did n over 12? Then what would it equal on the other side? Then we have to flip the other side. If we flip one side, we got to flip the other side. That would be tw over 2w minus 2t. You guys got that? Here, to make it simpler, this is the same as saying, what if I had 2 over 5 and it equaled a over b? Well, what happened if I did 5 over 2? Then it would have to equal what? B over a. That's essentially what we had done, but with a weird looking fraction. All right, what's our next step to solving for n? We got to get rid of that 12. To get rid of that 12, we're going to multiply both sides by 12 over 1. That would cancel this side, but this side is going to get multiplied by 12. Now we have our answer for n. It's going to be all that business on the right-hand side, but not one answer choice is shown that. Why? Because they did some reductification. So n is equal. We can reduce that 12 to 6, right? That's 6, and you got that 2. That'd be 6tw, and also that 2 will change to just 1t. So 6tw all over w minus t, and that is the answer to your question, answer choice D. This is a slick mechanical part of in terms of questions. This is a very good question with which to practice because then it makes all the other ones that they give you easier to deal with. All right, let's deal with radicals and exponent rules. This that we have in front of us, I see this 4 radical 2x. Let's do some basics. 4 radical 2x. Where did that 4 used to live? That 4 used to live inside. Actually, let me clean that up. Too many lines. That 4 used to live inside the radical as 4 squared. So 4 radical 2x used to also be 16 times 2x, which is radical 32x. So this is the same as this. Oh, but not only that, they're telling us that, here, something extra. Radical 32x is also equal to 16. You guys get how that works? All right, so there's several ways of solving for it. I know that Gabby Meister, she's the master of Desmos. She would plug this into Desmos and get her answer. I like doing it longhand because I just think it's easier. All right, I just gave you an explanation about how to deal with radicals, but let's see this particular question. How would we deal with it? So 4 radical 2x is equal to 16, but the question wants us to solve 6x. So then let's go ahead and solve for x first. First step, I'm going to divide 4 by both sides to get rid of it from the left-hand side. So it's going to leave me with radical 2x is equal to 16 divided by 4, which is 4. Next up, I'm going to get rid of that radical by squaring both sides. So that's going to leave me with 2x equals 16. Pausey. What's the question we need to answer? Now, some of you guys are going to go all the way and solve for x. And you can do that. You can go all the way and solve for x. X is equal to 16 over 2, which is 8. And then you can take that 8 and then plug it right into 6 times x, which would be 6 times 8. Another thing I like to do is take that 6x and put it right underneath the 2x. If I have that going on, take a look. There's a ratio. It's a 1 to what ratio? 1 to 3 ratio. So that means this sucker also has to be a 1 to 3 ratio, so your answer would be 48. But let's say we took that 2x instead and we solve for x. Again, I repeated this before, then it'll be 16 divided by 2, which is equal to 8. Now, a lot of students, if they had answer choice E and they had 8, many students would bite on that answer E and it would be wrong because what do we have to do? We have to take that 8, stick it in there for X. 6 times 8 is 48 also. So you can do it this way through ratios, or you could just straight up solve for X, but please be careful. Solve for that 6X. Not bad, right? I told you it ain't that hard, yo. It ain't that hard. You guys got skills to pay the bills. Remember this. When you guys get your test scores, the scores that you guys want, in the state of Florida, we're looking for 1330s and above because 1330 gives you a 100% Bright Future Scholarship. You're going to remember these words. He always told me I had skills to pay the bills. So I always tell you guys got skills to pay the bills. You don't realize it. You guys own this test, but you don't realize it. But when you practice, you start to see through it. All right, let's take a look at this guy. I got D marked here, which means certainly good for Desmos, but it is a hard question. Yeah, I'd probably use Desmos for this. Yeah, why even break my brain? But I'm going to show you how to do it longhand so you understand the big picture of this sucker. This guy, they're testing mechanics also. How do we get rid of the radicals? First step, we're going to square both sides carefully. That's going to leave us with x minus 2 squared. Oh, did you notice that? Even though we got rid of the radical, it doesn't get rid of the x minus 2 squared. It still stays squared x minus 2. You're just getting rid of the radical. A lot of students think it gets rid of the squared. No, it just gets rid of the radical. That's it. All right, what is that equal to? This is going to be equal to 3x plus 34. All right, next up, we're going to distribute the left-hand side. That'll be x squared minus 4x plus 4 equals 3x plus 34. Now I want to set this sucker to equal 0, so I'm going to subtract 3x and subtract 34 from both sides. Again, listen, subtract 3x and subtract 34 from both sides. I don't want to write down the subtractions. I'm running out of space. All right, so if we subtracted 3x from both sides, that will leave me with x squared minus 7x, because remember, we're subtracting 3x from both sides to get rid of this guy. Then we subtract 34. What is a negative 34 of the positive 4? That would be a negative 30. And then we set it to equal 0. Next up, we're going to have to factor the sucker. See, I'm explaining this so it's good for you guys to realize what this question is actually asking. So when you do plug it into Desmos, you're going to get a parabola, and you're going to see that your x-intercepts are going to connect in 2 points. But if we had to factor this, what two numbers would add up to negative 30 and the two numbers, I'm sorry, multiply negative 30, but add up to negative 7? It looks like it'd be an x minus 10 and an x plus 3. What is 3 times the negative 10? That'll be negative 30. What is a negative 10 plus a positive 3? That's a negative 7. I think we have our answers. Now notice, since it's set to equal 0, what if I took x minus 10? We did this before in a couple of other videos in the past. So x equals a positive 10. That is one solution. The other one is x plus 3 equals 0. So what will x equal? X will equal a negative 3. Now, either answer would be correct, 10 or negative 3. Either one, good to go, would be correct. But what is the question asking us? Chop, chop, chop. Is asking for the smallest solution. So negative 3 is the answer to this question. By the way, your negative 3 would have been found right here. Those are your x-intercepts, and your positive 10 would be found right here. So your parabola is doing some business at your x-intercepts like that. Since this is positive, but it has a negative 30 y-intercept, so that means your y-intercept is somewhere down low, right? So your parabola is doing something like this. Whoops. What is it? Negative 30. So your parabola is working something like this. You guys got that? Where you have a vertex that's going to be lower than negative 30. That's it. Ding dong, the witch is dead. Question number 20, which is also considered a hard question. Most students have answered this incorrectly. Let's take a looky-loo and see what's going on here, yo. Oh, what is that little mark right there? Hold on one sec. See if I can change it. Oh, man, I think I'm losing memory. Oh, you want to play games? All right, no problem. Let's see if we can wrap this sucker up, because now I'm afraid it's going to clink out on me. All right, here's our next step here. Since it's a question number 20, it is certainly going to be a hard question. Let's break this sucker down. Notice on one side, we have this number 4 to the 8c, right? The exponent is 8c, but it's also equal to this cube root of 4 to the 7th power. All right, do you guys remember this? Let me write 4 to the 8c. Now we got a base of 4, but we have exponent 8 times c. equals. What's another way to write that cube root 4 to the 7th power? You guys remember this? It would be 4. Remember, the exponent would be a fraction to the 7 over 3. Ta-da! That's what it means, yo. Now, if you were to plug this into Desmos, yes, you could plug it into Desmos. But man, this question is so easy. There's not much to do. The only thing you need to know is how to convert from radical to the number with an exponent that which is fractional exponent. Now they're just simply asking, what is the value of c? Well, we got like bases, so now it's all about the exponent. So we take 8c and we set it equal to 7 over 3. How do we solve for c? We're going to take that 8 and multiply both sides by 1 over 8, or divide both sides by 8, right? So what's going to happen this side is going to cancel out, but we also multiply this side by 1 over 8, or divide both sides by 8. So what does c equal now? It's going to equal 7 over 24, and that is the answer to this question. Now, if you wanted to put this into your calculator and make it a decimal, yeah, the decimal version of the answer would also be correct in the SAT. But once you get the fraction, just put the fraction and get out of Dodge. All right, question number 21. Oh, 2 more questions and we're hitting the hills. This is also considered a hard question. So what do you guys notice? The exponent and radical rules, they like to leave them deep in a test. So if you're truly uncomfortable with exponent radical rules, you need to work on those, then go hit them. Just a 15-minute session of dealing with exponent radicals, and then you own this stuff. Now, this is a classic example of a question that wastes time. In fact, hold on, let me see the next question. The next question. Yeah, same thing. All right. Like if I saw this question, I'd be like, oh man, I got to waste my time doing this. Or I could take the next one and say, oh, I'd rather do this one. Now, this one's going to involve quadratic formula. Do you guys remember the quadratic formula? Yeah, I'll just write it down. Negative b plus minus radical b squared minus 4ac all over 2a. You guys got that? Okay, now that we got that, what would I rather do first? Question 20 or do question number 21? All right, let's do question number 21 first so we can get this exponential and radical stuff out of the way. All right, notice first we've got 6 outside. I don't want to stick it back inside. Back inside the radical used to be 36. Let's keep it outside now. It's already outside. So that's going to be 6 times. I'm going to explain this one slowly. Now the next number, actually, let me rewrite that. My bad. Let me write it this way. 6 times. 6 times what? Now we're going to take this sucker right here. The fifth root of 3 to the 5th power is actually saying this. 3 to the 5 over 5. That's how you write it, right? The fifth root of 3 to the 5th power, it's written as 3 to the 5 over 5. Remember? Fractional exponents. Times, check this out. Now this guy, that's going to be x to the 45 over 5. You with me so far? To 45 over 5. All right, next we have times what? We got 2. How do you write that one? 2 to the 8 over 8. But we still have that x going on, right? So we got the 2 knocked down. Now we got that x times x. How do we write that one? Now it's implied that's x to the first power inside the house. So how do we write it? It's going to be x to the 1 over 8. Now remember, all those fractions, they're exponents. Just in case you're getting confused with how I wrote them, they're all exponents. All right, let's go step by step. They're just testing if you know some basic ding-dong rules of exponents. So that's 6 times 3 to the 5 over 5 is 3 to the first power, which is just 1, times, what's x to the 45 over 5? That's x to the 9th power, times 2 to the 8 over 8. That's to the first power, which is just 2, times x to the 1 over 8. You guys get the game? All right, now I'm going to take my whole number is 6. 6 times 3 is 18 times 2. That's going to be 36. And now notice I got my x's, right? That's going to be times x to the 9th times x to the 1 over 8. So if I have x to the 9th times x to the 1 over 8, oh man, I'm glitching out. Now I have to add the exponents. Remember, like bases, you have different exponents, then you add the exponents. So technically I've got 36. God, such a waste of time. 36 times x. And how do I take the 9 and the 1/8, I've got to add them together, but they have to be, um, what do you call it? Common denominators. So that means I'm going to have 72 over 8, right? Because it's supposed to be 9 over 1 plus 1 over 8. Again, 9 over 1 plus 1 over 8. So I need to have common denominators. So then I would add my 1 over 8. Oh boy, I have to check into this. I don't know how it looks on your screen, but I've got this so far. Times my, and that would be plus 1 over 8. So what is that going to equal? That's x, the exponent, so 17 over 9 plus 1 over 8. Oh, 17 over 8 might do. My bad, 72 over 8. Plus 1 over 8, which is going to equal 73 over 8. All right, so that's 36x to the 73 over 8. And that is the solution to all this business. But they just don't want that. They're telling us that it's got to be ax to the b power. So what is my a value? That'll be my 36. What is my b value? Well, I already have x, right? That's x, but it's going to be to the b. And that's 73 over 8. And the question is asking me to add a plus b. So I have to add 36 plus 73 over 8. Oh, this is such a ridiculous question. Sorry, guys. I should have omitted this one, but it'd be good. If you're looking for a higher score, like in the 700 or 650 plus, you got to deal with this kind of stupidity. All right, let's do it. 36 over 1. I hate these questions. And then we're going to add 73 over 8. We need common. Oh, that's why I put this in here to notice when you need to use common denominators. I need common denominators on the left-hand side. So I'm going to multiply downstairs by 8 and upstairs multiply by 8. 8 times 6 is 48. Carry the 4. 8 times 3 is 24. That'd be 2. Whoops, 288. Sorry about that, guys. 288 over 8. Hey, plus 73. So that'd be 1, 15, 16, 1. And that'd be 361 over 8 when you add these guys up together. So for this stupid question, your answer is going to be 361 over 8. Waste of energy and time. Now, since you saw this and you're like, forget this noise, I don't feel like doing all that work. Yeah, this is a question where you got to do all that work in carefully. Now, if you want to use Desmos and you're good at using Desmos, by all means use it. But man, it's going to be a mess in Desmos also. If you recognize this question, you don't feel like doing it, all right, then don't do it. Just come up with an answer, plug it in, and keep on moving. Because perhaps the next question will be easier. Remember that. Don't get locked up. This question is designed to lock up the high GPA student who feels challenged by this and doesn't want to walk away from it on test day. You have to, I reckon, if I see this question on test day free or something like this, no, I dummy answer and I skip this. I'll flag it for review and I'll come back later. All right, last question. This one, I wrote down a quadratic formula because I didn't feel like rewriting it again. What is your A value? Your A value is 2, your B value is -8, and your C value is -7. All right, let's get busy, carefully plugging in our numbers. So we got a negative B, right? We're going to do that negative B first. So here we go. A negative, what is our B value? It's going to be a -8. And then we have plus minus, radical, b squared, which would be -8 squared. So I'm just going to put that in there immediately as 64. And then we're going to minus 4 times a, which is 2, and times our c value, which is a -7. Oh, this is so weird. Let's see if it holds out. And then it's going to be all over 2a, which is 2 times, and our a value is 2. Ta-da. All right, let's do our business. What's a negative times a -8? That would be a +8. Now notice, I'm going to put an arrow within the question. We got that 8 going on, right? We got plus, minus. So what is 64 times a -4 times 2, which is -8? What's a -8 times a -7? That'll be +56. So what is 64 plus 56 is going to be 120. So inside the radical, we're going to have 120 all over 4. Now take a look at the question. What are most students going to be doing? They're going to solve all the way to the end. We don't have to. They're already showing our 8. They're showing our 4. And we got plus minus. And what's inside the radical? K. What does K equal? Your answer to the question is 120. That's the answer to this question. All right. I slowed down on this page because there's a lot of intricate little pieces that make these questions hard questions. But you guys know what's going on. If you need any additional information, you need help with this, or you need me to explain a question differently, just contact me. Text me 786 877 7231. 786 877 72, and hopefully it'll pop up. 3-1. Come on, baby. Show that 3-1. 3-1. Well, you got the idea. I'll catch you guys later in the next episode. Peace out.